Okay, let's talk about how to use pipes and what they are. So to start off here, I'm just going to open a new R script, and I'm going to install or load the tidyverse library. And again, if this doesn't work, you can go to packages, click install, and then type tidyverse, and be sure that you install the tidyverse packages. So what I'm going to do is basically show 3 different ways to do a sequence of calculations on a data set to get a specific result. And what that specific result is we're going to use the trees data set, which it's included in R. So down in the console, we can type trees and see that it has 3 columns: girth, height, and volume. So we don't need to read anything in because it's already included in R. So what we want, and I'm just going to put this in a comment here so we can see what we're trying to get. We want for trees with a girth over 18 inches. So we're only going to do these calculations for trees over 18 inches. So just these last 3. I want mean volume, mean estimated volume, which we're going to calculate by using the girth and the height. And this is a meaningless calculation. It's just a way to show how to do a calculation over and over again. And then the difference in volumes. So the difference between this volume and this estimated volume. So this isn't necessarily useful, but it's something that mimics something that we might want to do to a data set. And we're going to do this 3 different ways. And I'm going to talk a little bit about what those 3 different ways are first, and then I'm going to demonstrate them. So the first one is creating new data frames. So what we would do here is say we want a new data frame to equal step 1, whatever our step 1 is, and give it our data. And then we're going to make a second new data frame and say, I want to do step 2 with the results from the first one, which is new data frame. Then the second one is with nested functions. So the idea is to do this version, but just in one step. So you don't have to create a bunch of new data frames. And in this instance, what we would do is we would type step 2, and then in the first argument of step 2, we want the results from step 1. And so when we have this, when we're doing it this way, the way you read this is from the inside, the innermost parentheses, to the outermost. So it's going to do step 1 with data, and then it's going to do step 2, and it's going to use the output from step 1 in these parentheses. And the final way is using pipes, which is what this video is about. And if we use pipes, what we do is we say, take our data, pipe, this is the pipe operator, this % greater than %, pipe it into step 1. And what it basically does is takes data and puts it into the first argument of whatever function step 1 is, and then take the results of step 1 and pipe it into step 2. So it takes whatever comes out of this and puts it into the first argument of step 2. And what I'm hoping to do is to show, by doing these 3, the 3 ways of doing this, to kind of show, 1, how pipes work, and 2, why they are nice to work with. So let's do this first one first. So the first thing I want to do is filter my trees. So I only want the ones that are over 18 inches. And so I'm going to create a data frame called trees filter, use the assignment operator, and then use the filter function. So the first argument is a trees data set. The second argument is what I want to filter by. So I'm going to do greater than or equal to 18. And if I do Command Enter or Control Enter on Windows and run that, you'll see that I get trees filter, which is only the trees that are greater than 18. Now, the next thing that I want to do is create another data frame called trees calc for the calculations that I want to do. And I'm going to use mutate to add columns to the existing data frame, which is trees filter. So I'm using trees filter, which is the result of this, and I'm going to do a couple calculations. And the calculations don't matter so much. Remember, it's just kind of to get the idea of how we're doing this. So I'm going to rip through that a little bit quickly, but we're going to create vol_est as a estimated volume. And that's going to be equal to pi times girth divided by 2 divided by 12, because we want the radius, and then convert it to feet. Again, this doesn't matter too much here. And then multiply by height. And then I'm going to create another column, which is diff for the difference. And we're going to be the difference of the volume, so that's the original volume, minus the vol_est, which is the calculated volume. So if we do this, we see trees filter, sorry, trees calc. Now we have an estimated volume and a difference between the estimated volume and the actual volume. Okay, so if we look at what we want, we now have volume, estimated volume, and difference in the volumes, but we want the mean of each of those. So let's do step 3. I'm going to call, so the first thing that I actually want to do is get rid of some columns to make this a little bit smaller. And so I'm going to make another data frame called trees cell for select. And I'm going to select a few columns that I want for the future operations. So I'm going to give this the result of the last thing I did, which is trees calc. Then I'm going to tell it which columns I want to keep. So I want to keep volume, I want to keep vol_est, and I want to keep diff. So I can do that. And now we can see trees cell just has volume, vol_est, and diff. And now I'm going to calculate the mean of each of these 3. So this one, I'm not going to set it equal to anything so that it just prints out after it. So we're going to do summarize trees cell, which is the output of the previous one. Then mean vol for mean volume is going to be the mean of the volume. Then mean vol_est is going to be the mean of the estimated volume. And then mean diff equals the mean of the differences between them. And just to make this a little bit nicer looking, let's do that. So if we run that, we can see that we get the mean volume, mean estimated volume, and mean difference for those 3 that we filtered. And again, we didn't really need to do the select, but I wanted to just use it as an example of an operation that we could do. Okay, so that's option 1. And you can see it's pretty easy to follow what we did. We generated a bunch of different data frames. We could have named these all the same so that it doesn't keep generating, but then you'd have to go back and rerun all the code, and it might be difficult to troubleshoot where you went wrong. So the next thing we want to do is do this with nested functions. So we're going to do it all in one statement, following this, this method where you put the first thing you want to do here, then put that into the second function, and so on and so forth. So what we're going to do is start with the last function that we made, which is this summarize one. All right, so let's go here. I'm going to copy it and paste it here. And we know that we want trees select in that summarize function. So trees select is what comes out of this select function. So we could go and take that, copy it, and then paste it in place of trees select. Then we know that this select function wants trees calc, which is the output of this mutate function. So we can copy that and put it in place of trees calc. And finally, this trees filter data frame is what comes out of this filter. So we can copy that and put it in place of trees filter. So if we run this, I'm going to do Command Enter. You see we get the exact same thing, but it's a little harder to read than this stuff up here, right? So we know that we're doing a filter and then a mutate and then a select and the summarize, but the filter parameters are here, then the mutate is down here, then the select is over here, which we could organize that a little bit better by doing that, just hitting enter, and then the summarize is down here. So they're kind of disjointed. And if you know what you're looking at, and maybe you've coded a lot in the past, this might make sense and be easy to read, but for a lot of people it is not. So we're going to do the third option, which is using pipes, which again, this is, we want to take the original data, pipe it into step one, and that's going to put data as the first argument of step one. Then we're going to use another pipe, which takes the output of step one and puts it into step two, which is basically what I just did manually here, where I took all of step one and put it into the first argument of step two. And then you can just do this so on and so forth. So I am going to do this again by copying and pasting. And the reason I'm doing this is I think that by copying and pasting and then editing it into a piped statement, I think it helps sort of visualize what is actually going on. So, and what's nice about this is it's pretty linear. And so what I'm going to do, I'm not going to save this yet. I'm just going to have it print out. So this the very first one we want to do is filter girth is greater than 18. So again, we're going to use entirely pipe. So we don't need trees here because our pipe will put trees in the first argument of that filter statement. So I go trees, pipe, filter, and then I want the results of that to go into the first argument of this mutate. So if I put the mutate here, we don't need trees filter because that's coming in from the pipe. And then I can do another pipe here. And the next thing I want to do is this mutate. So I can copy that mutate, paste that there. Oh, I already did that. Whoops. Sorry about that. Let's go back. The next thing I want to do is the select. So take the select, put it as next, and the pipe is going to replace, they're going to put that first argument in, so we don't need that. And we don't need the select anymore. And then finally is the summarize. So if I go pipe and then summarize, and again, you don't need that first argument because that's what the pipe is doing. Okay, so this should do the exact same thing. So if I click anywhere there and run, you can see that we get the exact same output as all the other methods that we've used. And again, this is a little easier to read. So here I could read this as, okay, I take trees, filter it, for we filter girth is greater than 18, then I create a vol est column and a diff column, then I select volume, vol est, and diff, and then I summarize these three things. So you can see how you can read and follow this a lot easier than the other two methods. Now, if I want to save this, you do it just like you would do with anything else. I could call this trees sum and use an assignment operator. And if I do that, it's going to pop up just like that, right? So if you don't assign it to anything, it's going to show up in the output. And if you do assign it to something, then it'll pop up here. Now, so that's pipes. One last thing I want to show you is there now, as of R version 4, there is a native pipe in R. And so if this operator here, this percent, greater sign percent, is part of the magrittr package, I guess you would call it. I've never actually said it out loud, but it's part of the tidyverse. So it comes when you install that. But now there's a base one and it works the exact same way. It's just a different symbol. So we can do this the bar that's next to the backslash and then a greater than. So you can kind of imagine that as like a little arrow. So it looks kind of similar to the original pipe. And if I replace all those, and run again, you can see that this tree's sum is the same. Or I can also, again, delete this and run it without assigning it, and it'll spit out the exact same as previous. So 3 ways to do the same thing, and hopefully a decent illustration of how pipes work and how they can help your code look a little bit more readable. Now, one last thing, we'll go over this in future videos, but you could also take this and do another pipe and take those data right into a ggplotline to plot. And so if you want to do some filtering in order to make a plot, but you don't want to save it as a separate data frame, you could do that as well. So that is pipes.